Hello, I'm Laura Marshall.
And I'm Melinda Rose, and this is Light Matters for April 11th, 2012.
On this week's show, nanobubbles deliver drugs and genes to specific cells. A Navy Robocopter targets pirates. Flexible solar cells could affect future electronics designs. We give you a sneak peek at the technology transfer program at Clio 2012, and we bring you some other notable business news.
Using light harvesting nanoparticles to convert laser energy into plasmonic nanobubbles, researchers in Texas are developing new methods to inject drugs and genetic material directly into cancer cells. The nanobubbles are generated with a pulse of laser light striking a surface plasmon. By matching the wavelength of the laser to that of the plasmon and dialing in just the right amount of laser energy, the team can ensure that nanobubbles form only around clusters of nanoparticles in cancer cells. In tests on drug-resistant cancer cells, they found that delivering chemotherapy drugs with nanobubbles was up to 30 times more deadly to cancer cells than traditional drug treatment and required less than 1/10 the clinical dose. Rice University's nanobubbles are not nanoparticles, which so far cannot exclusively target cancer cells. Rather, they are tiny air pockets and water vapor created by the laser strike. The bubbles form just below the surface of cancer cells. As they expand and burst, they briefly open small holes in the cell surface and allow cancer drugs to rush inside. This method, which has yet to be tested on animals, will require more research before it is ready for human testing.
Unmanned aircraft will be able to distinguish small pirate boats from other vessels when an Office of Naval Research-funded sensor starts airborne tests this summer. Called the Multi-Mode Sensor Seeker, the sensor is a mix of high-definition cameras, mid-wave infrared sensors, and laser radar technology. It will be placed on a robotic helicopter called Fire Scout to autonomously identify small boats on the water. Its advanced automatic target recognition software will greatly reduce the hours sailors have to spend sifting through streaming video from the unmanned vehicles searching for a single ship. It distinguishes target boats in congested coastal waters using LiDAR to calculate the dimensions of an object and compare them to those in a database. Human operators can then analyze those vessels in a 3D picture. The algorithms have been successfully tested in shore-based systems against vessels at sea. This summer, it will be tested aboard a manned test helicopter against groups of 7 small boats or so in a military sea range off the coast of California.
A flexible organic polymer solar cell less than 2 microns thick could have implications for the design of future flexible electronic devices. Electronics made of organic materials, such as plastic, are appealing because of their flexibility and their ability to be used in biological systems, textiles, and moving machine parts. The flexible organic solar cell was fabricated on a micrometer-thin polymer substrate. The cells maintain their performance after being stretched repeatedly and display a power conversion efficiency equal to their glass counterparts. The work is reported in Nature Communications.
Photonics Media is the media sponsor for Clio 2012's Technology Transfer Marketplace session.
That's right, we're happy to be playing a role in promoting the session, which takes place on the exhibit floor and provides valuable information about how to move great ideas from the lab to the marketplace. Earlier, I spoke with Mark Tolbert, CEO of Toptica Photonics and a member of the Clio Tech Transfer Committee, about what attendees will see at this year's session.
This year we've got an exciting program as the beginning of our 3rd year. We're starting on Thursday, May 10th, so make sure you get there on time and start off early. We've got 2 sections that we're going to focus on this year. The first part is about bringing technology from the concept into industry, and we're teaching people how to do that. With that, we're going to use folks from the University of Arizona to tell us how they transfer technology out of the university into commercial product. In View Technology, Bob Bridge is coming in to focus on commercialization lessons that he's learned in transferring technology from university into industry. And NASA is joining us as well to tell us how we can bring their technology out from a government entity into the commercial markets. Followed by that program, we're getting into a great presentation of technology-ready innovations that are really ready to come to market. And for speakers there, we got people coming in from NASA Ames Research Center, as well as international universities in Scotland and other parts of the world, followed by an associate professor that has technology out of UCLA, and a CEO and founder of a new technology company by the name of Spectrifier that has innovative new ideas around portable interferometers focused for biophotonics as well as physical sciences. And to round it all off, we've got a terrific guest speaker this year, Dr. Mark Kasovich from Stanford. Mark's joined us to come in and tell us about his technology and what they're doing in innovative technologies to bring to market. And he's also a great example because he brings technology from the industry, as he's been a chief technology officer at AOSense Corporation as well.
Great, thanks Mark. It sounds like it's really turning into a really international presentation.
We're certainly trying to make it that, and we're having some fun doing it too. So we're looking forward to bring people out of the talks into industry and learn how we can do that together.
Thanks for joining us on Light Matters, Mark, and we'll see you in San Jose. For more on the Tech Transfer Program, Photonics Media is co-sponsoring a webinar with OSA on May 2nd at 1 p.m. Eastern Time. Visit photonics.com to register.
Optics maker LightPath Technologies says it will focus on products for the infrared market under a new growth strategy. LightPath will concentrate on low-cost molded infrared optics for imaging, sensing, and defense, laser optics for industrial applications, and optical assemblies for laser light collection and management for industrial and laser instrumentation.
Citing decreased defense spending, Applied Energetics says it is suspending most of its government work to focus on making lasers for industrial applications. Revenue from contracts with government agencies or contractors represented about 90% of its total revenue for 2011.
Well, that's it for this edition of Light Matters, the industry's only weekly newscast. We'd like to hear from you. Tell us what you like or don't like about our program. We welcome comments and suggestions at lightmatters@photonics.com.
You'll find links to share and subscribe to Light Matters by clicking the Share with Friends button on our video player.
Thanks for watching, and we'll see you next week.
My career in optics have been very fruitful. So I do telecommunication in the past. Right now I'm doing a work that is related to develop laser that is high power that can actually do eye surgery.
I study extreme and novel forms of polarization. And so what we're hoping to do is better microscopy, making other scientific systems better by using our knowledge of optics and then teaching other people how to better use light to perform other types of science.